Hello, I will start presentation with a real-time detection system based on YOLOv7 for high collective injection molding product using Moire pattern. I'm UungSub, the author of this study. I'm majoring in smart factory conversions at Jeong University in Republic of Korea. The plans are a brief introduction and related works. Next, the subject of this study is explained. Next, I will introduce the experimental environment and evaluation, and last, the conclusion. Fourth industry revolution is driving many innovations in manufacturing. Smart factory is a very important issue in fourth industry revolution. Smart factory refers to a method that enable more efficient business operations by collecting and analyzing various types of big data generated in the manufacturing environment to improve productivity and quality. Implementing a smart factory has now become an essential element to strengthen companies' competitiveness and sustainability. In particular, the quality control process for inspecting defects in the manufacturing process is one of the processes that requires a lot of man hours. So, companies are trying to implement a real-time inspection system for automation in the quality control process. However, many problems need to be solved in order to inspect coated highly reflective injection mold products. There are three most difficult problems in coated highly reflective injection molded products. First, various types of defects occur irregularly. Second, it is difficult to distinguish between their defects and dust on the image. Lastly, it is difficult to see various defect types in one optical system. We implemented real-time inspection system using YOLOv7 and Moire pattern. Our main contributions are summarized as follows. First, we propose a method of detecting very small defects using the offset detection algorithm. Second, we propose an optical system design optimized for cylindrical high reflective products. The introduction of automation in quality control in the manufacturing industry has revolutionized manufacturing as repetitive tasks can be replaced by machines. Mechanism that has to be performed by humans in the past caused various human errors, and inefficiency. Studies for the improvement of such an inspection system is continuously being actively conducted. This is a simple block diagram for a vision system operation. The most important thing here is the optical acquisition step, and in this step, an image that can be inspected for defects must be obtained with uh, appropriate optical system. Next, how to inspect defects. In this study, we try anomaly detection through object detection algorithm, not the previously used anomaly detection method. For a computer to analyze image perfectly, it must not only focus on classifying different images, but also try to accurately estimate the concept and location of object contained in each image. Object detection is generally used for human behavior analysis, face recognition, and autonomous driving. Studies to improve the performance of object detection are being conducted very actively, and recently studied YOLOv7 show very good performance. This is the development roadmap of the framework of general detection methods. The YOLOv7 model was proposed by Wang. YOLOv7 includes several trainable facts of previous so that real-time detectors can significantly improve detection accuracy without increasing inference costs. The speed and accuracy exceed other detectors in the range of 5 to 160 FPS. It also supports both mobile GPU and GPU device from edge to cloud. As you can see in this graph, YOLOv7 performs much better than other object detectors. So this model can be deployed in practical working applications and utilized in real-time industrial inspection system in future. Moire pattern was proposed by author. Moire pattern is a pattern in which 13 patterns repeat regularly. The Moire pattern can make the small curves of three-dimensional shapes stand out more. We studied to inspect defects on the surface of the cosmetic case, which is a coated high reflection injection molding product using thin learning. We propose a real-time inspection system using the YOLOv7 and Moire pattern. This image is the target product we studied this time. The size of the product is high of 32.52 millimeter and diameter of 22.25 millimeter and has a cylindrical shape. The cylindrical shape. The defect occurs on the top and side, and the types that occur are as follows: scratching, bad point, wear, finger pointing, and pollution. The target product is a product coated on the surface of injection molding product. It is difficult to accurately occur a defect image due to diffuse reflection due to the high reflex surface. We constructed an optical system that can inspect defects in all aspects of the product by taking images of the product using 10 cameras, dark field and bright field and YoHan. Among the type of defects that occur in the product, bad point is difficult to distinguish from dust on the image. We used the Moire pattern to solve this problem. In the image on the left, both dust and bad point are treated as and 3. On the other hand, in the image on the right, in the case of bad point, the stripe is distorted and is clearly distinguished from dust. When the Moire pattern was applied to all space, some defects were not visible. In order to solve this problem, we have implemented an optical system where dark field and bright field can intersect. If you look at the picture below, you can see that pollution is observable only in the dark field. Existing anomaly detection techniques have various classes of defect type and were difficult to apply to manufacturing inspection systems that need to inspect irregular defects. We proposed a system that uses an object detection algorithm to inspect defect by dividing defect type into each class and running. And if no objects are detected, it is just normal. This is concept diagram of real-time inspection system based on YOLOv7. The takt time, the actual production line, is 1.2 seconds. We use YOLOv7 for taking and analyzing 10 images within 1.2 seconds. This is the network structure diagram of YOLOv7 where captured images are processed. The experiment was conducted in an actual production line of cosmetic case manufacturing in Gyeonggi-do, Korea. and equipment was designed to satisfy the existing production capacity of 1.2 seconds for each. The input part source the product and puts it into the inspection system regularly. This is optical system setting mentioned above. And in the opening input part, NG is pushed through the cylinder. The monitoring parts show images and statistics being inspected in real time. We aim to secure inspection speed and detection capability applicable to the actual manufacturing environment. Therefore, the evaluation index of the experiment evaluated the values of risk detection and over detection when the actual product was inspected by the inspection system. This is specification of the hardware. We tested 1,000 products per each test. This table shows the comparison result when Moire pattern is applied and when it is not applied, and when YOLOv4 and YOLOv7 are applied. When Moire pattern was applied, risk detection improved performance by about 5 times and over detection by more than 2 times. Compared to YOLOv4, it was confirmed that YOLOv7 improved by about 30%. The Moire pattern was able to obtain very effective results for highly reflective products, and the applicability of the inspection system using YOLOv7 to industrial applications was also confirmed. But it is true inspection performance is still insufficient for application in industrial application. In addition, it is difficult to properly secure defective samples in an actual industrial environment. In order to these problems, our future study will be a method to solve the blessing balance problem. Thank you for listening my presentation.